to help make sense of this, let's say that we have a 0.9 centimeter drop, as we had on the data that we actually took in class. Okay, this 0.9 centimeter drop gave us a potential energy change. As the ball dropped, the potential energy decreased. Now, if the change of potential energy equals the kinetic energy, then we have an equation that we can solve for the velocity. In this case, it's mass times your 980 centimeters per second squared times 0.9 centimeters equals 1/2 mv squared. It might be preferable to write this as mg delta y equals 1/2 mv squared and solve it symbolically, and then to plug the numbers in. But whichever way we do it, we end up solving for v, and we can easily see that with these numbers, v ends up as 42 centimeters per second. If we compare the 42 centimeters per second with the velocity that we could actually observe as the ball rolls down the ramp and declines 0.9 centimeters, we'd see whether we have a clear conservation of energy by potential energy being equal to potential energy change being equal to the kinetic energy change. In this case, potential energy loss as the ball drops will be equal to the kinetic energy gain. Now, actually, that doesn't happen in this situation, because ideally, in this case, for a ball on a smooth ramp, the translational kinetic energy would be 5/7 of your potential energy change, the magnitude of your potential energy change. Again, assuming a potential energy loss, which is the only way the ball is going to roll down the incline. The 5/7 is an effect of rotation. And I'm saying this 5/7 off the top of my head. If I happen to be wrong about this 5/7, we'll find out later when we get into analysis of rotational motion. So remember that I've claimed that a sphere rolling down a smooth ramp will have only 5/7 of its kinetic energy in the translational direction. The rest is going to be in rotation. In this case, since the ball lies down a little bit lower than it would on a straight ramp, because you have that groove in between the two rails that hold the ball, the kinetic energy of spin is actually going to be even a little bit greater, and the translational kinetic energy will actually be somewhat less than what we see here.